And here is my favorite part again. It's advanced robotics. This slide is wrong, but I'm gonna skip it. We have collaborative robots. A collaborative robot is usually a robot arm. And of course, it says collaborative robot, it's a cobot. As I said before, we don't look to replace humans. We aim to work with humans to make the job easier. In that particular example, the girl is moving the arm without having to touch it, right? Let's say she wants to pick up something very heavy. She cannot. But it can show the robot the movement that it needs to do, and the robot will pick the object up and she won't do it. Here I have another example. This robot helps this man here. Let me try to, I guess I cannot skip. I cannot skip, so you have to see it. So this robot helps this man in some sort of assembly. You don't need to have robots do everything. There are some things that are just too complex now to, I mean, with the technology that exists, you can do it, but it's too complex, too expensive. So you can still have a human do the dexterous work, the hard work, and you can just have the robot assist. Doesn't have to pick heavy loads, it can just help. And here is another example with KUKA medical robotics team. So I showed you before that there are already Da Vinci and all those robots that work in medicine. Some of them, the doctors don't even do anything, but they are there to assist in case anything happens. The robots are not ready to take this kind of responsibility. And if some of you may have seen that viral video that a robot did the first surgery on a grape, that was also a very huge step in medicine because it requires very high precision. So you can see that they still work with humans. Something that actually needs to be taken into consideration in collaborative robotics is human safety, of course. So there's not every robot can be a cobot because it needs to have high level, high accuracy sensors that can sense the human that's next to them. I read so many papers on that. They need so many things that they need to take into considerations, and they have robots that when they sense a person, they will just stop. They shut down. Of course, you don't want this kind of heavy robot to hit a person in the face. So not every robot is a cobot. That's not a cobot. I mean, I can work with it. It's very small but it doesn't have the intelligence to understand when my hand is near, so I could get hurt. So you also need human intelligence to step away from a robot as well. Here we have soft robotics. It's a subfield of robotics that has the fabrication of robots composed of compliant materials instead of rigid links. So all I showed before was wheels and rigid links. But soft robotics introduces the concept of a soft robot. Here you can see many different kinds of robots that use silicon or something like silicon, not great with material science, but it does go, you do need a lot of material science to go into this. And as you can see, before we imitated cars and humans, and now we can actually imitate animals. So a snake, spider, even a fish it has a lot of science behind it, because you have to carefully examine how all of these animals move and to try to replicate that, because what we've done up to now was just the arm and the wheels, which is relatively easy. And these usually work with pneumatic or hydraulic. Actually, it doesn't, because it needs air to move or water, depending on the application. Of course, a soft gripper, which is very known. I actually have it. Do we have soft gripper? You can find. So of course it can be both, can be a robotic arm and a gripper, which is basically a soft robot, but of course this is not complex, it just opens and closes, does not move around. Here we have Sophia robot, which is a soft pneumatic helically interlayer actuator. This is actually a robot I worked on when I was doing my master's in robotics, and I did some simulations on how big and small these layers of these strands can be, in order, because if you're going to medicine, you need to be very specific, you need to be have a high accuracy, you have to have safety. That's why you use soft robotics. You can't put a rigid thing in a person. I mean, you can, but it's painful, so you're trying to minimize that. And we did a research on how small that can be, because this is specifically for long gap esophageal atresia, which is basically when kids' esophagus stops there and there's a gap. There is a surgery, of course, to fix this. They use it to it moves. So you move like some rigid parts, and it generates the esophagus. Or you can either put how do you call it, implant from another person, or from. Obviously, that's a very hard and invasive surgery to do, because they actually put it on the back of the babies and they move all those strings. So if you want to do something minimal, this is a solution. And again, this was using pneumatic supply. And all those black things you see is the constraints. So the robot will go up and on the side. And here we have micro and nano robots. So of course, we have all of these robots. We want smaller ones, especially in medicine, again, biomedical field. They already have some ingestible robots that you can use in order to track something like, is the intestine clogged? They will put something in, you will eat it. If it stays there, it means it's clogged. They can tell by the GPS or other sensors that are on it that is not moving properly. But I would like to introduce these robots. Well, just don't want it to be too loud, but. So as you can see, these robots are even more advanced. And then it disappears by the dish. The robot self-assembles using the folding process that is triggered by heating. After this, the robot can run along designated trajectories. It can carry objects, it can clear obstacles.
it can swim, it can execute a variety of tasks. And when these tasks are done, the robot can recycle itself by dissolving its body into a liquid.
This is the first robotic device that completes a full life cycle from its birth to its death. Typical robots consist of electronic devices. Our robot is made based on controllable materials. This is the biggest difference.
The robot's body has embedded in it a small magnet, and this allows us to control the robot by programming a magnetic field. In other words, the robot has external programmable actuation.
Currently, the robot is controlled remotely by a person. We'd like to advance this robot and make it more intelligent, such that it can make decisions by itself.
Origami-inspired robot designs have the potential to be faster, cheaper, and easier to fabricate than robots created using traditional manufacturing processes.
It is easier for such a system to be used closer to humans, such as in the human body. For example, you could regard this robot as a controllable drug capsule or a surgical tool, which can be removed after its use in the body.
Can imagine ingesting these robots and then controlling where they travel in the body. And once they arrive at the correct location, they could form themselves into active instruments that can actually manipulate and help through the healing processes. For the short term, we see these robots as potentially extremely useful in inspection tasks because they are small and they can travel through very intricate, small, narrow pipelines that are difficult to inspect with today's technology.
So of course, anything that has to do with medicine is still in testing stages because there's so many things to take into consideration in medicine. They actually, for the soft robot that I showed you before, they did some testing, but in pigs in testing, not human. So still has a long way to go. Another advanced robotics is swarm robotics, which you have to coordinate all those robots to work together, avoid each other, and perform a certain task. It can be their walking, driving, flying, and the last picture shows that they actually combine each other and create another robot. I'm not sure if that actually exists or if it's just the potentials, but still very fascinating. We have here an example of robots that can write their own code. Okay. So I mentioned all those algorithms and all those machine learning. So these robots can write their own code by using pathways language model. So it perceives the data and then it corresponds to it. I think this is very recent research.
Programming the robots using traditional programming languages, you just tell the robot, arrange the block as we see here, the top right, arrange the block in a square around the middle, make the square bigger, so forth and so forth. What we see here is that using LLM, long language models like ChatGPT, that instruction array, the blocks in a square around the middle, that translates to an instruction to ChatGPT, let's say dedicated ChatGPT, and that ChatGPT creates a code, and that code is sent to the robot. So using natural language, these days, to use natural language and make programming of the robots more accessible using artificial intelligence.
And here we have
The Ocado Smart Platform, or OSP, is a configurable end-to-end commerce, fulfillment, and logistics platform built to meet the unique demands of online grocery. OSP enables a winning proposition for customers while delivering the best economics for retailers. A highly personalized online journey delights customers with intelligent features that inspire new choices, help them to find their favorites, and anticipate when they're running low. For retailers, this means improved customer acquisition and retention and greater share of wallet. This enables powerful retail in any local sector. One of the benefits of the benefit of the
before I go into this, and if you have any questions, you can ask me. The last robot showed a combination of what I mentioned before, cobots, because they did work with humans, and it did show swarm robotics, so they all work together as a whole, and they use AI and all those tools to understand the objects that they carry and so on.
Or just to note that online participants can also ask questions, and all answers will be available for all users at the online platform as well.
Does anyone have any questions? I'm going to take that I explained it very, very well. That's why you don't have any questions. Here you can visit our online classroom. We have the quiz that you can do in order to get your certificate. I tried to make it as easy as possible. So to be fair, you could have done it before you came here. And it also has the workshop PDF, and I will actually upload tomorrow all of these presentations, and I will actually add additional material, and the recorded session, because we did record this, will be uploaded there as well. The only thing is just you have to register first, but they're all there, all free. And you can also find our previous topics. We did Internet of Things and soft skills, all of the presentations in there, and they also have the link to the recording as well, which we have a YouTube channel for this classroom as well. Yes, and we're also doing data analytics and AR, VR in upcoming trainings. We already shared the 2 dates. Mr. George, are we doing it the same date as planned? Yes, we're doing it On the 16th of February, we're doing data analytics, and 1st of March, we're doing AR and VR. Not sure if we're still doing it at this location. We will update you with that information. And here, if you please can fill this form and let us know if you like the presentation, if you would like to have more interactivity and so on. Of course, for us that are physically, we'll have a workshop later. For those that you're online, we will eventually come to you and do a workshop. Set up.
Well done, Cotin. It was very, very interesting.
It was beginner to intermediate. It wasn't advanced because I knew that there will be people that are not don't have knowledge. So I tried.
Building a road.
Thank you as well. We're gonna do a workshop now. For the online participants, that was it. I hope you enjoyed the presentation. I hope you review the material that we have online. And of course, if you have any questions, feel free to send an email or send a comment on the platform. Thank you again. I'm looking forward to seeing you in Malta and having the workshop with you.
Thank you. Thank you. Bye-bye. Bye.
Bye. Listen to Zoom.